Now that you understand the format of the try-catch block, here's an example of a different way that catch blocks can be used. We can add more than one catch block onto the bottom of a try when we have specific exceptions we are looking for so that we can handle each one differently. So in this case, I'm catching a divide by zero exception and printing out a more specific error message, you cannot divide by zero, versus just catching any general exception and then printing out a more generalized error message. We can add as many catch blocks onto the try as we want as long as we put all of the specific ones before the general one. Since as the flow of program control comes through your application, the first exception to trigger is the only one that will trigger. So in this case, when we debug, you can see that we hop down into the divide by zero exception because it's the first one that meets the criteria of the exception list that we've been given. When defining your exception inside of the catch block, you can also define a variable after the exception type that you're looking for. When you define the variable, the object type exception will be created in that variable, and you can use any methods or properties of class exception inside of your catch block. The message property typically describes the current exception that's taking place in the application. So when I run, I can see you cannot divide by zero because that's what I've written out here on line 23, but I also see the message of the exception object, which is attempted to divide by zero. Sometimes providing this message information to the user is appropriate versus writing out our own messages. Another section of the try-catch block that we need to talk about is the finally block. Since programs frequently request and release resources dynamically during our execution time, then we often have problems where that resource will continue to stay open in the event of an exception because the code that needed to close it was probably up here at the end of the try block. So the finally block is a optional part of the try-catch structure. So you don't have to have a finally, as you've seen in our previous examples, our try-catch ran just fine. But if you do add the finally block, then it will always execute in the event of the catch or the try finishing successfully. So adding the code that releases our resources into the finally block, or adding in any steps that your program needs to take regardless of whether there was an exception or not, is the best place to put these. So if the try block executes successfully, then the finally block will execute immediately after the try block terminates. If an exception occurs inside of the try block, the finally block executes immediately after the catch block completes. If the exception is not caught by the catch block associated with the try, or if a catch block associated with the try block throws an exception itself, the finally block executes before the exception is processed. So we can ensure that even if the program terminates due to an uncaught exception, the resource will still be deallocated and the finally will still run. I know that might seem confusing, so the best thing to do is to run it and step through and see how the program handles it. So when we run our mathematical operation in the try, the divide by zero exception is caught. The catch block prints out the two statements, and then we can see that we jump into the finally, in which the result is printed. So what we get is you cannot divide by zero, attempted to divide by zero, which are the two statements from inside of the catch, and then the result, which is zero. Looking at this a different way, if I change these values into something that will not cause an exception, then we do our calculation, and as soon as the try block ends, we jump down to the finally, and the result is printed. So in this case, this line executes whether there's a problem or not. When building your programs and thinking about that idea of robustness and programs that can handle themselves and not crash and have graceful execution, then the use of the finally block is almost absolutely necessary in order to make sure that the program continues to do all of the things that it should do and function normally, even in the event of a runtime exception.